What is shear failure and why does it happen? Have you ever wondered why some materials break unexpectedly? One common reason is shear failure. So, what exactly is shear failure and why does it occur? Shear failure is a type of mechanical failure that happens when a material or structural component fractures due to shear stress exceeding its shear strength. Shear stress is the force that makes layers of a material slide past each other along a plane parallel to the force applied. When this sliding force becomes too strong, the material cannot hold together and fails by cracking or breaking along a diagonal or sliding plane. This type of failure usually occurs when the internal forces within a material reach a critical point. At this point, the bonds between particles or fibers can no longer withstand the load applied. You might notice shear failure as diagonal cracks in beams or components that are subjected to bending and shear forces. For instance, in reinforced concrete beams that lack adequate shear reinforcement, diagonal tension cracks can develop. This happens when shear forces exceed the tensile strength of the concrete, leading to a brittle form of shear failure. The mechanics behind shear failure involve the interaction of shear forces and tensile stresses. When a structural element, like a beam, is loaded, shear forces create internal stresses that act parallel to certain planes within the material. According to stress analysis principles, these stresses can be resolved into principal tensile and compressive stresses at about 45 degrees to the axis of the applied load. If the tensile stress surpasses the material's tensile strength before the shear strength is reached, diagonal tension cracks form, which initiates shear failure. Understanding shear failure is important because it can lead to sudden breakdowns in mechanical and structural systems, often without much visible warning. This type of failure is common in gears, shafts, bearings, and beams where shear forces play a significant role. For example, gear teeth can fail prematurely if the shear forces exceed the material's capacity, resulting in mechanical breakdowns. To prevent shear failure, engineers focus on several design aspects. Material selection is key. Using materials with high shear strength and good resistance to shear stresses is essential. Geometry optimization is also important. Designing components with shapes and cross-sections that reduce shear stress concentrations can help. In concrete structures, adding stirrups or shear reinforcement bars increases shear capacity. Understanding how forces are applied and supported is vital in designing components that can safely withstand shear forces. Shear failure is a fundamental mode of mechanical failure that explains many breakdowns in products and structures. By studying how shear forces act and cause materials to fail, engineers can design safer, more reliable systems. This knowledge helps clarify why certain products or mechanical parts fail unexpectedly, guiding improvements in design and material use.